Welcome back. So far we've been talking a lot about knowledge of language, and we've been talking as the object of inquiry, and we've been talking a little bit about why we might be interested in that, and then we've spent most of last week talking about how we might go about studying that, namely using scientific method. So today we're just going to hone in a little bit more on the object of inquiry here. And what is knowledge of language? Well, it's a property of the mind, we said last week, and so some has to be mentally represented, and there's this idea of grammar being represented in the mind, and that's what we'll talk about now. So let us just reconsider how we approached knowledge of language last week. So we said that linguists are interested in this thing that we call knowledge of language, and I'll often call it KOL for short now. And we basically ask this question: what does a speaker hearer know when they know a language? And notice that know a language, not know a specific language. So really what we're interested in is the capability, if you will, of the human mind to learn language and to learn it in very specific ways. Right? So languages have properties. Language, as a property of the human mind, has specific properties, and these determine things that are impossible. Right? So we could talk about impossible languages, and they determine things that are possible. And so one way to think about this as a property of the human mind is that the human mind has a certain ability, a certain linguistic ability, what we might call a faculty. Specifically here, we'll later call this the faculty of language. And linguists propose and evaluate scientific theories about this knowledge of language, about this faculty of the mind for language. So knowledge of language involves both storage and computation. That's what we've seen last week. There are some parts that you have memorized. You remember, for example, in Walbury, you have to remember that camina means one thing. I can't remember what it was, girl or boy or something like that. And that in English, the sounds boy represent the same thing, the same concept. So there's part of things that we have to memorize, and then of course, I gave you some more complicated examples, even with plurals that we might have to memorize. And then we also saw that there are things that you have to compute. So remember that WAC test, which showed that it's really the rules that people know about plural formation rather than just having memorized all of them, because they can come up with new things on the fly, a property called creativity that we'll talk about in a moment. And so the system of stored knowledge and rules in a speaker hearer's mind is what we'll call a mental grammar. So notice the really important point here is that this is the system that is stored in a speaker hearer's mind. So this is a very internalist position. We're interested on a more or less individual level, what is a human capable of doing with this faculty of language? What kind of knowledge of language do they and can they have? So let's look at a couple of properties that language has and that are pretty universal to all languages in the world. So the first one we'll look at is what we call infinite embedding. So consider a sentence like this: the truth is out there. That's a sentence that for most people that have some sort of an English grammar is grammatical. Now we can take the sentence and put it inside another sentence. So we can embed it. So we can say something like, Fox Mulder thinks that the truth is out there. And we can do that again. We can say, Dana Scully knows that Fox Mulder thinks that the truth is out there. And then we could speak about someone else and do that again. So we might say something like, someone doubts that Dana Scully knows that Fox Mulder thinks that the truth is out there. And you see the sentence already got so long I couldn't even contain it on the slides here. And you could keep going with this forever, right? Well, not literally forever. At some point you'd probably die of thirst and hunger if you just kept on talking. But I think it's pretty obvious at that point that we could always add something. So there is a capability here that the mind has, the computational system specifically, that is part of this faculty of language, that allows us to produce infinitely long sentences based on some properties such as infinite embedding. So infinite embedding shows that mental grammars must be computational systems that are yielding, well, hypothetically, infinitely long sentences. Right? If we neglect the factors of the universe that determine our lifespan and other needs such as sleep and memory limitations and so on, you could perhaps produce a very long sentence and not even remember what you started with or what you were talking about by the time that you decide to conclude saying that sentence. Another property that languages have that I've just mentioned is linguistic creativity. So linguistic creativity refers to the fact that we can produce and understand and judge sentences that we have never encountered before. So it can't be the case that we've just sort of learned different sentences. So for example, if I say Fox Mulder has an office on the 4th floor of Chandler House, I'm pretty confident that you have not heard that sentence before. And nonetheless, you can perfectly well understand what it means. In fact, it's even more bizarre than that, because if you've ever been to Chandler House, you know that we have 3 floors. We have a ground floor, we have a basement, and then we have a first, a second, and a third floor. But we don't have a 4th floor. Nonetheless, we can produce that sentence, we can all understand what it means, so we can be creative. And similarly, if I change something slightly in that sentence and I say, what floor does Fox Mulder have an office of Chandler House? You see that what I really did is I took the 4th floor, turned that into a question, moved that to the front and left the rest sort of dangling there. So you might think, well, there are lots of grammatical things that I do like that. Question formation kind of works like that. But it turns out actually that some things we can't leave dangling there. And even though that sentence is very similar to one that you've just learned about, you immediately are able to judge that that sentence is an unacceptable example of the kinds of mental grammars that you and I and other English speakers carry around in their heads. So linguistic creativity is not just about the ability to produce or to perceive, but also about your grammar recognizing when something that it doesn't know anything about is in conformance with its rules and when it's not in conformance with its rules. Of course, what precisely those rules are that have been violated in the second sentence here, you will find out as you study more syntax. Take a sentence like this, very famous sentence produced by Noam Chomsky to illustrate linguistic creativity. Colorless green ideas sleep furiously. Now that sentence doesn't make any sense. At least not if you don't concoct a very complicated story around, green politics and the ideas that people have and how they've become really bland and therefore they're colorless. And now they focus on other issues, and so they've put those ideas to sleep, but they're still really important, so perhaps they're sleeping furiously. You can sort of construct meaning to it, but really what on first glance this sentence quite clearly illustrates is that the meaningfulness is also not the important thing. So you might say, the meaning of a sentence like 1 is really clear, but that of 3 certainly isn't. And nonetheless, you have very strong intuitions that this is a good example of a sentence that conforms with your mental grammar of English. And that becomes even clearer when we jumble up those words. So furiously sleep colorless green ideas is, perhaps semantically just as pointless a sentence as sentence 3. But again, your mental grammar will tell you immediately, no, that's just word salad, Florian. That's not a good example of an English sentence, independently of whether it intends to mean the same thing as the sentence before or not. So creativity demonstrates that mental grammars must be able to produce and parse sentences that a speaker hearer has never been exposed before, Therefore, they must be rule-based. And it shows, moreover, that, as an implication of that, mental grammars then must clearly define the set of possible sentences while simultaneously excluding all the impossible sentences. Right? If it didn't define the set of all possible sentences, then you couldn't understand sentences like 1 and 3. If it didn't exclude all the impossible sentences of a language, then you wouldn't be able to recognize that sentences 2 and 4, albeit that in the case of 2 you are able to attribute meaning to it, and in 4 you're not able to attribute meaning to it just in the way that you were for 3, you wouldn't be able to know that those are not good sentences. So those are some of the properties we can conclude that mental grammar must have as a property of the human mind. So what is it that a mental grammar might encode then? Well, let's think about those kinds of sentences we've just seen and what it might be that a speaker here has in their head that allows them to fulfill these criteria. So with only a few things that we'll call rewrite rules, which is a specific kind of rule system that we'll use, we can define a model of a mental grammar that is capable of both creativity and infinite embedding. We'll make one assumption, namely that grammar treats groups of words that occur in the same position as equivalence classes. So this is something that already came up in the reading if you've done it. The idea that, for example, I see Susan, John, Ephraim, April, and so on behave very similarly. Right? What do they all have in common? Well, they're personal names, and moreover, they behave like nouns. They can occur in exactly the same positions in languages, and you can more or less replace them with one another. That doesn't change the acceptability of the sentences, it just changes the referent. So the grammar treats them as a single category. And it turns out that an important property in order to account for creativity and infinite embedding is this categorical treatment of various mental entities. All right, so let's have a look at how we might derive some sentences. So we'll come up with a little toy grammar of an English-influenced mental grammar here, and I'll just give you some rules and I'll walk you through them, how they work. So the idea of a rewrite rule is that you have some symbol, and then if there's a rewrite rule for it, you might replace it with another symbol. So if I have a symbol S, which we use for sentence, but also as the start symbol, if you will, seeing as, every sentence has to start as a sentence, we can say, well, a sentence consists of an NP followed by a VP. An NP here refers to a noun phrase, a VP to a verb phrase. But really they are arbitrary symbols. I could call this, X is replaced by Y and Z, and then write rules for what Y and Z might be replaced with. And so really what I do here is then I say, well, whatever this label NP stands for, you can replace that with a D and an N, where D stands for a determiner, so things like the, an, and a noun. So these are things like John, cow, mug, keyboard, mouse, and so on. Now notice I've put some braces, parentheses around the D here. That's just to indicate that's optional. Right? We could, of course, write two rewrite rules. We could say, NP can be replaced by just a noun, or NP can be replaced by D followed by a noun. So this just allows us to be a bit more compact in writing our things. Sometimes things are partially optional. And then we say, well, okay, this other unit, VP, might be replaced either by just a verb, or by a verb followed by a C, followed by an S. So a C is a complementizer, so those are words like that and which that we've seen in infinite embedding we can attach new sentences to, and then, well, we put in another sentence, so we start over. So actually this is the property of recursion, which you might have heard about. And this is what precisely allows for infinite embedding. So I can put a new sentence inside another sentence, and then so I will replace this S with another NP-VP, and then I can make more decisions. I could replace it with, this NP and this VP, and then I'm done. Or I could replace it with this NP and then this VP down here, and so I can include another sentence, and so on. And so these labels here, the categories, D, N, V, C, and S, they eventually, of course, we can come up with structures of valid sentences here, right? Based on categories, based on equivalence classes that can follow each other. And then, of course, the goal is to replace those with words that have those categories or that fit those equivalent classes, in other words. So let's employ that, right? It's perhaps been a little bit abstract. So here are the rules that we came up with again, and now let's see how we can use this toy model of a very, very simple subset of an English mental grammar to produce some sentences that show the properties from before. So to make a very simple sentence, first of all, we could do something like this. We start with an S. We replace this S by a sequence of NP-VP, right? This is what the first rewrite rule here tells us. And I've color-coded these things a little bit so that you can keep track of the constituents, right? And so the NP then, we follow this rule and replace it with a D followed by an N. And this VP here, we replace with this V followed by an NP, not with this bottom one VCS. So now we have another NP here, and we replace that NP, according to this rule, with a D and an N. So we're left with a string that only has categories left. It doesn't have any of these things with a P left at the end. Really what we want to avoid is to have phrases left over. We have to replace until we can't replace anymore. We can make choices every time that we replace between things that might lead to the end of a sentence or things that keep it going. But the way that a rewrite system works is you have to rewrite until you're left with what you might call the primitives of the language or the grammar or the model. And in our case, these are the categories. And now I can go and replace those categories with anything that fits in those equivalency classes. Or in other words, anything that has that category. So the noun I might replace with fox, and the verb I might replace with the verb want, and then the determiner here I might replace with the word the, and then the noun here I might replace with the word truth. And that gives me the sentence, fox wants the truth. Very similar to the truth is out there that we had earlier. We've just made it a little bit simpler, because without there now we have adverbials, and then we'd need more rules, and we'd need a much bigger slide to fit that all on there. But it probably illustrates the same thing. And just with that, I mean, you can replace any which one of these with various other things. Fox wants a truth, Scully doubts the truth, and so on. You can see that creativity is already enabled. Right? There are quite plausibly sentences that we could make of this form with words that that you have never heard or uttered before. Now let's have a look at how we might implement the recursive pattern. So we do the same thing essentially. We start with a sentence, replace that with the NP-VP sequence, replace the NP with a D and an N, and replace the VP with VCS. So with this one on the bottom here, which crucially includes another sentence, so something else that I can replace. Now I have to replace this S with something, and as a little shortcut, what I've done is I've just gone here. So you see I've made this red and I've made this red. So I'm going to replace this S with what I've already worked out S can be here. Right? So namely with this DN, V, DN sequence. So we are left with DN, V, C, DN, V, DN. So we use the sentence here, fox wants the truth, right? We've seen that that fits wherever S fits. So since S fits here, that will fit in there. So we can now make the sentence, Scully believes that Fox wants the truth. Scully replacing the noun here, the determiner, which is optional, we've left out. Then for the verb, we use believes. Then for the complementizer, we use that. And then for the sentence, we use the sentence that we know is a good sentence, Fox wants the truth, that we've derived earlier. So hopefully you can see how a very simple system of rewrite rules that a speaker could have memorized delineates exactly the set of all the sentences that are possible in our toy model of English. I have to emphasize this is a toy model because, of course, there are lots more complications that you might have already noticed that we haven't sort of taken care of, right? Of course, there are many more types of sentences that we can compute. On the other hand, there's also things that are neglected, like the present tense marking on want here and so on. But we could build extra rules into our system to take care of that. And it also gives you a complementary set of all the things that are impossible. Namely, a sentence is impossible if I cannot derive it with these rewrite rules. Right? That's something I might say. And so the task of a hearer that hears a sentence they've never heard before might be to figure out, in reverse, what steps of rewrite rules I could take to get back just to my starting symbol, or the sentence symbol. So with that power, you might now be able to figure out why a sentence like, that the truth wants Fox, is ungrammatical. Have a little think about it. Maybe pause the video if you want to. I'm going to count to 5 and then I'm going to tell you. All right, so hopefully you figured it out. And given our rewrite rules here, well, the obvious thing is, this starts with something that fits the category complementizer. And the only way that we have to get this in there currently is if it's preceded by a verb, right? So it has to be part of a VP, it has to be preceded by a verb and followed by another sentence. Well, it's followed by another sentence, but it's not preceded by a verb. Therefore, it already can't be a possible replacement for VP. It's not a possible replacement for VP, which is the only for S. Well, then it can also not be a possible replacement for S. Therefore, it's not a possible sentence of this toy model of an English mental grammar. So that's really almost everything that I wanted to illustrate in this video already. Of course, there'll be more, and we'll be talking about some complications, but this will be setting our stage a little bit. So let's just recap what we've seen, and what I hope you remember and perhaps are convinced by at this point. So what we call a mental grammar is a computational system, and it has an input and an output. In our example just now, we had words with their equivalence classes as an input, and we had sentences as an output. Right? So you take a number of words, use the rewrite rules, and you can come up with a sentence that you can fit them into. And then you can output that sentence by replacing those categories that fit their equivalence classes. Now, the objects that form the inputs and the objects that form the outputs of these mental processes, well, they exist in your mind somehow, right? Somewhere I've stored these words and I've associated them with their appropriate category. And then on some level, I also, well, when I produce that sentence, in order to be able to pronounce it later on, because there's some stuff happening in between. For example, I have to think about the phonology. I have to do the motor planning and so on. But at the stage where they come out of syntax, right, which is the part of the mental grammar that's responsible for forming sentences, well, that will be a mental object of some kind, right? It's somewhere there in your mind, that sentence that you've constructed. And so really what we want to say is that these are mental representations of some entity, right? This entity exists as a thought or as an idea or as information of some kind. It might represent something in the real world. but it has to be represented somehow in your brain. And a great question is also not just what are the rules, but what is actually represented for these things, right? If we have a sentence, if we have a word, what's actually represented in the mind? What does the mind actually store about it or have there temporarily in memory? And one thing that we can say at this point already is that mental representations are abstract symbols. So you've seen that in order to account for creativity, we had to not use the concrete words, but rather categories that generalize over them. So we said, a noun phrase consists of optionally a determiner and then a noun. And then we specified for all the words that the speaker knows, whether they're determiners, whether they're nouns, whether they're verbs, and so on. And so these mental representations are abstract symbols that mentally represent some type of information or some type of externally real entity. So to conclude, we can think of a mental grammar as a computational system that maps one type of mental representation to another. And perhaps it's worth just pointing out that this is not just true if you're studying knowledge of language or the human faculty for language, but even in vision systems. For example, Zenon Pelishin, as a very prolific writer on visual perception. And the visual perception system works just the same way. All the visual solutions, visual illusions that you might be familiar with, such as the Muller-Lyer illusion, where you draw a line and you draw inward arrows on one and outward arrows on the other, even though they're the same length. One of them will look shorter than the other to you. Well, that happens because you have a system like this as well. It follows some rules in reconstructing a mental abstract representation. And it does that based on fixed rules. And so even if you know that the lines are the same length, you can't see them as being the same length.